Nintendo Switch Lite motherboard only. Let me show you what's going on. And you can see there is a few things missing. Our port and a whole lot of pads that were still attached to the port. Oh look, there they are. Anyway, that's going to be the job ahead of us here. For your orientation purposes, when we're working on side B, this is where we'll be working. And when we flip to side A, we'll be working here. First thing I'm going to need to determine is what traces I need to run. These two are really the ones I have questions about. Everything else has obvious traces. These don't have anything going to them, so I don't think they're going to be an issue. That has a trace, that has a trace, that has a trace. Those two. These guys, but they don't need them. This guy, these guys. So these two I have a little bit of question about. So let's scrape off there and see if we have the remnant of copper there. Conformal coating. Okay, that looks like it's just all conformal coating there. We'll just worry about the ones we have obvious traces to. The Nintendo Switch Lite does not have a Pi 3 USB, which is a USB-C control for docking. The first thing I'd like to do though is clean up these holes real good. So you let a little bit in there, not a lot. We're set up to do some cleanup. In order to do some cleanup, I need to set up my equipment. And while I set up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the associate links in the description. If you go to my video description and click on one of these links and buy any of this equipment, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you and won't cost you an extra dime. We'll switch to side A temporarily. If we can't, go ahead and get this out. If we need to add more, we'll add more. There we go, that cleaned up. Very good. Should probably look at the rest of this board just to make sure. I do see some solder balls around the fuel gauge. That could be an issue. We'll have to see. Let's do some cleanup. Almost looks like he used solder paste in this area, which would be bad. I'll need my ultrasonic. Random solder balls everywhere. Random solder balls on a board is not a good thing. Definitely don't want to do any rework with random solder balls laying around. They tend to fly off into something you don't want them to, or short something you don't want them to. All generally undesirable things. These are the common fault testing zones that I follow on side B. I mainly just test these test pads right here. Find ourselves the ground. That one is ground. None of the rest should be shorted, and none of them are. Now we're going to switch over to side A and have a look. Find ourselves the ground and test the capacitors around the M92 T36 first. Okay, everything looks good. Check around the BQ24193. Everything looks good. Make sure we don't have a short on this coil. We don't. How's our invincible fuse? Still being invincible. Now I'm going to check around this fuel gauge as well. Normally wouldn't, but today it seems like a good idea. Alright, everything's checking out okay. Doesn't mean it is okay, but we'll find out. I apparently did not hit record for this entire soldering section. We have run the 8 jumpers. Definitely routing challenges on these guys. And these guys, and we're going to have to be careful when we're securing it down. This guy's got a little bit of lift, so we'll probably want to tack him down first. Our next step is going to be to secure it all down, prep for a new port, and put a new port on. Hopefully I'll record that part. I'm kind of done being upset about the recording. Let's go about securing down our jumpers. I got some stuff that was supposed to be clear, but it looks more like snot than it does clear, and it does not cure particularly clear, so I think we'll just stick with the green stuff for this job. I'm going to put a little down on that one, and then we're going to tack it down. Tack it down, I mean we're just going to hold it down to the board and give it a partial cure. That way it will be down flat on the board, secured down on both sides where possible. You could technically just cover the whole wires too and scrape it off later. That's always an option. Not a bad option. I don't find the need to always do that. Doesn't take a lot of UV gear to secure them down. While we're working in the area, we don't have to be too concerned with up here as far as thickness or anything like that. The port is not going to sit on these traces. We're free to get messy. The reason why we're securing these down with solder mask is when we go to flow that port on, the solder that I pre-tin the port with will have its own surface tension and will begin pulling up to a degree, and if these jumpers are loose, they'll suck right into the port. Surface tension can be your friend or it can be your enemy. In this case, we are combating it from being our enemy. Okay, I think that's everybody. We're going to stick the lamp on, step away, let it cure. I'll let you know that this mechanic solder mask that claims to be Cure on AliExpress is really not. It looks like snot. I think it would look worse off than the green stuff, so I don't advise you use it. Everything should be rock solid now. Excellent. Ready to proceed with the next step, which will be prepping our jumpers for tinning. Going to lightly scrape the enamel. We could just burn it off too, but this will also give us a good indication if our jumpers are nice and sturdy. Just lightly gliding them now. Pressing down. I'm just trying to get a nice surface scratch. That's all. Crank on our fume extractor. Add some flux. Tin our pads. And our jumpers. Doing the pads first. We're doing some enamel burning on some of these. We didn't get them real good with the grinder, but that's okay. Not a big thing. We don't necessarily need to clean the flux here. Not too used up. Client provided us an actual Nintendo Switch Lite port, so we don't have to do any grinding. That's awesome. But we do have to do some prep. And we'll just paint our pins here. That can be nice and puffy. There we go. Go ahead and place our port. We will need a shield. Place a shield for protection. Man, it's a lot of glare. I'm gonna put a shim on this shield here. Cut down the glare a little bit. Won't hurt to have some protection on the Wi-Fi IC either. Okay, as ready as we can be. We're going to use rapid air movement, and the idea here is to raise the temperature of the board enough to wet the solder. We're not necessarily trying to wet the solder with direct heat. By moving the air nozzle rapidly here, it will slowly raise the temperature, and will never be in one place long enough to burn the plastic. I've seen some other people suggest you need to have exact temperature profiles for every device, but in my mind, kind of impractical. You know, most hot air stations have like 3 presets. I guess they do make a few hot air stations out there that have more, but not mine. Okay, hopefully we have wetted. Press down now. Move the heat. I'm going to continue holding it down until I see evidence of drying. Let's give a delicate nudge and see how we feel. Feels pretty solid. Let's take a look under our shield, make sure we didn't damage the connector more. No, it's just as damaged as it was. I think it will still be fine for usability. Check our outer ones when you're worried about the inner ones. Sometimes you can neglect to solder the outer ones. That one's not soldered. Boy, none of these hardly are making contact. I think we'll give this another reflow. Sometimes when you're running jumpers like this, it can take a few tries to get it down too. Yeah, that one's solid. That one's going to need help. That one's solid. Those are going to need help. And that was solid. So we're good on all the pads. I don't mind having to do the jumpers here. I hope the jumpers underneath connected. Didn't need a bridge. Connected. 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 I don't know about that one. Or that one. I feel like we're making good contact there. I may have to bring in the micro pencil. Steady this here. There we go. Just need something that can hold solder at the tip a little better for these guys. Connected. Yeah, that wire's moving. That's connected as well. Very good. I believe all of our jumpers are connected. Clean up. I don't know why we're cleaning up too much right now. We still gotta get these anchors done. Over side A. Getting plenty of solder. Rub it in. Scoot on front. The back ones need help. And rub it in with the 120 watt. Looking better. Let's get a little more in. Much better. Nice feed through. I hope you're getting value out of this video. Just a reminder, if you find you're not ready to tackle this, I do offer these services, both locally and mail-in. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. If you mention this video, I'll give you 10% off on your repair. Okay, we're ready to perform some tests with our modified iPhone Power Squid. We'll use our Nintendo Switch Lite connector. Make sure this battery connector is still worthy. It's plugging in okay. And with our OEM charger, we're going to activate, see if we get anything resembling normal behavior. Plug it in. Okay, what we want to see, just kind of a steady climb in amperage without any hanging. And it looks like it's booting to me. Let's power it down, reset again, turn back on. We're going to flip our charger and see if it'll activate on the other side. And it looks like it's activating on the other side. And booting. Excellent. Now, as I don't have the housing, that's about all the testing I can do. I believe the port is going to be sound. Everything is connected. It's activating on both sides. It doesn't dock, so we should be good. And that's all there is to that one. If you'd like to see a video where I actually recorded the soldering, I think you'll enjoy this one here. And I'll see you there.